Number 7, planet Venus. We have a 225-day orbit, and that's the period. And we were given the mass and an almost circular trajectory. Well, but we know that, right? Because these ellipses are not very elliptical. Their eccentricities are very small, very close to zero. We're going to calculate the radius of the orbit and the orbital speed of Venus as it circles the sun. All right, so let's find the radius first. That's the first part of the problem. So as we are always doing here, we're going to set the centripetal force requirement, mv squared over r, m times 4 pi squared r over t squared, for this case because we're dealing with a period here, is equal to the universal gravitation acting between the sun and Venus, the orbiting body. All right, so centripetal force is equal to m times 4 pi squared r over t squared, and we're going to set that equal to the gravitational force acting between the sun, big M, and Venus, little m, and that goes over r squared. Okay, so we're going to cancel out the mass of Venus, and we are looking for the orbital radius. So all we're going to have to do is, we know that we can get to here, r cubed over t squared is equal to gm over 4 pi squared. So just multiply each side by t squared. And we're going to get that r is equal to the cube root of all of this stuff in here. So r is equal to the cubed root, or you could make it to the 1/3 power if you like that better. So we get gm t squared over 4 pi squared. All right, and just for fun, because it is so much fun, why don't we do a quick dimensional check here. We know that g is kilogram meters per second squared, Newton, times meters squared per kilogram squared, times, so we got g, that's for g, and for mass we got kilograms, and for time squared we have seconds squared, and then everything on the bottom here is dimensionless. So let's run this through. Kilograms squared on the bottom, get rid of kilogram on the top. We have seconds squared, canceling seconds squared, so we end up with meters squared, and when we take that to the 1/3 power, we're going to get meters. All right, we're in good shape dimensionally, so at least this has the correct shape. Now all we have to do is put all the correct values in for each of those things, and we should be in good shape. So what do we get? We get r is equal to the cubed root of all this stuff, 6.67 times 10 to the negative 11 Newton meters squared per kilogram squared. We could almost just not even put the units in, because we've already collapsed them down to the units that we know we need, which are going to be meters cubed inside, but force of habit dies hard. All right, so mass of the sun is 2.0 times 10 to the 30th kilograms, and T is 225 days, which we're going to have to convert to seconds. Give me a second to do that, please. And handy dandy calculator gives me 1.944, a little excessive on the precision, times 10 to the 7th seconds squared, and we're divide all that by 4 pi squared. So when we do all that and take the, it's cubed root, when we do all of that, we come up with, gives us a radius of 1.1 times 10 to the 11th